Viral Shah, who wears many hats. He is co-founder and CEO of Julia Computing, but also an author and a computer scientist. Welcome to the Data Exchange podcast.
Thanks, Ben, for having me here.
Yeah, it's a long time coming. Fellow gaucho.
Oh, yes, of course.
Yeah, I'm a gaucho math. Yeah, math PhD. Yeah, years ago. All right.
When were you there?
I'm not gonna reveal. I don't want to date. I
That
don't want to
makes
date
sense.
myself.
Very, very beautiful campus. Some of
Beautiful.
the best times.
I love it, and also kind of underappreciated the technical community, I think.
Yes.
Yeah. All right, so let's start with Julia, and so I looked at my Twitter feed. I first tweeted about Julia on March 1st, 2012. I think after I saw Jeff's talk in Stanford. I don't know if you remember. I think that was kind of the coming out of Julia in many ways, right? So it came out a few weeks before, but that might have been the first public talk, right?
That was the first public talk. We had sort of this, I remember the date because it's a Valentine's Day announcement. The blog post was on February 14th. And we were just so thrilled to have an invitation from Stanford to speak about it.
So describe briefly the origin story behind Julia.
Oh yeah, I always love to tell people how it came about. So the roots of Julia go back much before when we started the project. So we started the project in 2009, and it was the four of us. Alan Edelman, who's a professor at MIT, Jeff Bezanson, Stefan Krapinski, and myself. And the four of us are sort of we bring very different things to the table. Like, on the one hand, we have a professor of pure mathematics, Alan Edelman. We have Jeff, who's sort of a compiler, person. Stefan, who has sort of this huge experience with data science, with designing languages, building production-grade systems. And then my personal experience in the field of computational science, sort of bridging many of these things together. And so all of our careers were sort of progressing to the point where when we came together in 2009, and this was just an email thread, which I instigated in sort of connecting up all four of us. And it really was that, look, we've all been suffering this two-language problem. The phrase two-language problem had not yet been coined, but when I tell the story, I can use it. And it really was sort of like, when I look back at my PhD, I had, all this algorithmic exploration work in MATLAB and then rewriting it all in C++ and MPI for scaling it. And, Alan, Jeff, Stefan, everyone sort of had the same experience of using multiple different languages to get a simple project, a simple research project done. And we said, you know what, like maybe it's time to explore if we really sort of can have a single language that can have all the ease of use of Python or MATLAB, SAS, whatever it is that the domain experts want, the scientists, the data scientists, the engineers. And then, can that same system, the same language be used for getting high performance, parallel, scalable GPUs, everything you can imagine. And if you think about it, it kind of doesn't make sense to write the same program twice, right? Once in Python and then in C++. And that was sort of what led to our work on Julia. The most amazing thing about our origin story, I think, is, while discussions were sort of going on for a while, and I distinctly remember the ultimate frisbee grounds of UC Santa Barbara, where Stefan and I used to talk about,
Black Flag or whatever. What's the name of the team?
I kind of don't remember.
Tide or something. I forget. Yeah. It's a famous team. Yeah.
Oh, the UCSP team was called. It's gonna Black Tide.
Black Tide. Yeah. It's a very famous ultimate frisbee team. Yeah.
Very famous ultimate.
So, by the way, before you continue, so quick question. So you folks were talking about this around 2008, but at that point, did SciPy and Numpy exist?
They were in very, very early stages. I think you had to be a super early adopter of Numpy and SciPy. Numpy was, almost, okay. SciPy was really, really rough around the edges. I actually wrote some of the largest SciPy programs back in the day then. There's a tool I wrote called Circuitscape, which was in MATLAB. No one used it because it required MATLAB and it was, too clunky. We moved it over to Python, but it was, we didn't have the solvers. I had to write all the sparse linear algebra myself that I needed. But I'm one of the authors who published in one of the first SciPy, well, I don't have the first, but one of the early SciPy conferences. But that experience also fed into what Julia needs to be. And that's sort of, 2009, I think, is when we wrote first line of code.
And so I guess parsing what you just said, so the vision is to kind of solve this two-language problem of taking MATLAB and making it scale or making it faster, right? So, but has that played out? Fast forward to today, so your original thesis has been exactly.
I think so.
Yeah.
I would say that our original thesis has been validated, I mean, it's not just MATLAB, right? It's increasingly more Python, more Python. Of R. A lot of people come to Julia from the other end. They come from C++ because they're like, if I can have this performance without having the verbosity of C++, that's phenomenal. And if I'm working with data, for example, right? We often see, for example, people using Julia for very large data sets, just because the compiler and the language are so fast that, especially if your data can fit in memory, like a big machine, right? Like nowadays you can get a terabyte of RAM. It just tends to be simpler to use Julia and work with your data set in memory than sort of go through, one of the various other options that are out there. Like I've seen people replace Spark workloads with Julia. I've seen people replace Pandas workflows with Julia, and so on and so forth.
So going back to 2008, so to what extent, do you think that you guys have basically adhered to your vision, or has there been a slight deviation? Because usually, the journey of invention is not a straight line, right?
That's a very interesting question. I was just recently giving a talk, and I went and revisited the Why We Created Julia blog post. And if I think about sort of, the core thesis, as you mentioned, right, sort of having performance and productivity in one single language that can bring people of different communities together, I would say that has largely worked out. Back in the early days, there were, the way we thought about the language, the way we designed the language, we definitely, got more bold as time passed by in terms of bringing in some of the fancier features, like, I'd be hard pressed to name exactly which one we brought where. But if you think of it, right, like Python doesn't have metaprogramming, MATLAB does not, do pass by reference, for example, or R has sort of this non-standard evaluation kind of stuff. And we decided early on that we want to be sort of truer to computer science and sort of have a language that was more in the Lisp and functional programming tradition of languages. And it was not obvious at that time whether domain specialists, right, whether if you're a statistician or whether if you're a scientist or a numerical analysis person who are used to these different languages with their idiosyncrasies, like, there was this worry in our minds that maybe they will demand those same idiosyncrasies in a new language. But then as we announced it in 2012 and we sort of started seeing the community grow, it became very clear that there was this hunger for, having real computer science in a numerical, scientifically oriented language in data processing system, and I think Spark and Scala were a fantastic example, especially in the data world, to see that happen. A lot of stuff that you'd have seen in R and SAS before.
So where does Julia fit today, in the sense that I think it's okay to say that Julia is a general purpose language, right?
Yeah, absolutely.
But then the thing about so I guess when Julia came out, I was super excited. A lot of people were super excited, and then people started pointing out, well, the challenge that Julia will have is ecosystem,
Absolutely.
right? So if you look at, for example, data, it's you need an ecosystem to do a bunch of things, from the data cleaning, data frames, all of this. So where does Julia fit today in terms of the other other languages, in terms of, is it something that I use only for part of what I need in my data project, or does it have enough of an ecosystem that I can do uh, I can account for most of my needs within the Julia ecosystem, from visualization, data cleaning, all of these things, right?
I would say that ever since we've gone 1.0, so we announced in 2018, the 1.0 release of the language, everything became stable. And that has just led to a growth spurt in terms of sort of having these complete sets of libraries that allow you to do a lot of things that you want to do. Now, depending on what you're doing, maybe you will find everything in Julia, or maybe you have to fall back on something else. And Julia becomes a part of a project rather than the full project itself. Of course, my personal goal and the goal of all my co-founders and the Julia core contributors is to have natively, completely native Julia-based workflows. But
is it Viral? Is it an ecosystem in the sense that, is it mostly written by you folks, or is it increasingly written by others?
By the community, actually it's the opposite. Most of it is written by the community, and our contributions are sort of small in comparison. They're important because they tend to be sort of at the core of the language. But the Julia data ecosystem, so we have a GitHub organization called Julia Data, which has all your data frames, analysis stuff, all your different kinds of, loading different forms of data, a bunch of new arrow support that's coming up online.
And you folks don't pick winners, in the sense that there might be multiple libraries trying to do the same thing, and then users are free to just discover which they prefer.
That's just generally how open source works, right?
Yeah.
And what we do is that we play a role, the core group, within the Julia community, some of us play the role of convening the ecosystem. So if we notice like some, two obviously similar things happening, then we are like, hey, maybe you guys should talk to each other. But then sometimes there is a completely different approach of doing the same thing, right? A completely different set of abstractions in how you do your data analysis, for example, right? So for example, we have this, the data frames.jl ecosystem in Julia, which is, if you came from pandas or R, you'd find it to be very familiar. But then there is this whole sort of queryverse ecosystem, which, sort of is modeled more along the C# link style of, working with data.
I thought you were going to say SQL.
Well,
is there SQL? Because people love SQL, right?
Yeah, but SQL, I would say that a lot of the stuff underlying the system is very relational in many of these systems. So I would say kind of SQL's underneath the hood, and you can always call SQL. I mean, SQL is such an overloaded word nowadays. It's hard to sort of say what it is.
So so when you started out, and when you first released in 2012, fast forward to today, has the user of Julia changed? What's the user profile?
That's a very good question. So we started doing this Julia survey for the last couple of years, and so we're sort of getting some more insights into who comes to Julia.
I have it in front of me right now.
Perfect.
No, go ahead. Yeah.
I would say that 2012 was when, the contributors started showing up, right? People who would work on the language stack and so on and so forth. As we went into 14 and 15, the package manager was starting to become really usable, and there was a core set of packages beginning to form. So that was the time when the package authors, the library writers started showing up. So all your math solvers, all your different data structures, all your data formats, file formats, image processing, statistical analysis, all that stuff started coming together. And I would say that as we hit 1.0, over the last 2 years, we started seeing professional users. So a professional being, I might be working at a company where I don't use Julia, but I am an open source contributor at home, or I'm a researcher at a university. So in those roles, I'm already using Julia, but I haven't been able to bring it into the enterprise. And starting 2018, ever since we went 1.0 and we started seeing some of these libraries become really high performance, we've seen a lot of commercial usage of Julia sort of pick up.
So because of Julia's roots in scientific computing, I imagine that's a core part of your user base, right? The scientific computation community, which there is the academics in that community, but also there's the government researchers and maybe even people who work for firms that supply into government. So, yeah.
So, the government tends to do many things that the rest of the world doesn't do, right? The government does, so many different scientific projects and so many different data projects.
They might still use Fortran, right?
They still use Fortran, right?
Yeah.
Like the US Census still is built on Fortran. And, people who design submarines in the government also, have old Fortran CFD codes. When I say government, it might be a supplier, not necessarily an engineer in the government. But the government is such a large and complex organization, right? So it's hard to paint it with one stroke. So for example, the Federal Aviation Administration was coming out with this new avionics standard for a new system for collision avoidance of aircraft. So when two aircrafts come within 30 seconds of each other, there's a system that gives an alert to the pilot on, hey, there is you're within 30 seconds of a collision, and this is the evasive maneuver you have to take so that the collision is avoided. And this system has worked very well for the last 30 odd years, but now air traffic has become so much more congested, and there was a need for a new system. And the FAA decided, along with the researchers and people who sort of wrote the spec, that Julia is the right language to specify what this new avionics standard should be. So an aircraft manufacturer or system integrator now, gets a document with a Julia code that exactly tells them what they need to build and reproduce, in their onboard systems. So
what areas, Viral, would you characterize if you were to take a step back and look at the ecosystem right now? What are the areas where the libraries are particularly strong, and what areas would you like to see more contributions?
So that's a very good question. I would say that our scientific and mathematical libraries are very strong. Solvers, if you want to solve optimization problems, logistical problems, operations research, differential equations, all that type of stuff. We have probably a more complete ecosystem than anything else that is out there. The second ecosystem, which I would say is rapidly getting there, or probably is almost already there, is our data processing ecosystem. So we have some of the fastest CSV file readers out there compared to even Pandas and R, highly multi-threaded, highly performant, and able to work with more native data types than might be supported in some of these other systems. So the data processing, the visualization, plotting, all that stuff is pretty solid. Our parallel computing system, I would say, is also fairly solid. So it's very easy to do a large distributed data processing job, by using just some very simple primitives that Julia provides.
Is this MPI?
We have both. So we have an RPC style distributed computing module that just uses TCP/IP, so works out of the box in Julia on all the operating systems. And then for the people who want to go on the really like the big iron, the supercomputers, there's also MPI support.
We need a Julia API on top of Ray. I don't know if you guys are following Ray.
I've been following. I had a chance once to interact with some of the Ray authors, and I think it should. I hope to see it soon. I hope to see it soon. Ray is really cool.
So you started out in 2008. You folks were talking about the two-language problem, right?
Also, let me. I'm just going to interrupt you for the ecosystems, right?
Yeah.
So
go ahead.
I was going to just touch base on the machine learning ecosystem, which is also very robust in Julia now. So you can call TensorFlow, you can call PyTorch, but we have native Julia native Julia neural network libraries like Flux and KNet. And the amazing thing in Julia's machine learning is that it integrates with the science.
But
right?
is there a Julia equivalent of scikit-learn?
Yes, it's called MLJ.
What's it called?
It's called MLJ.
Okay,
so
great.
Machine learning in Julia, the name was modeled after MLR, which was machine learning in R.
And generally, I think I would characterize, just looking at Julia code, that it's fairly accessible to anyone using Python.
Absolutely, absolutely. I always tell people it'll take you a day if you're a Python programmer to sort of start writing a first useful Julia program, but mastering some of the concepts might take you a bit longer, because just like mastering any system and its new abstractions takes time.
So I guess going back to the origin story, which is the two-language problem, I'm looking at the survey. I think the reality is people will still use multiple languages, right? So like in your survey, I think depending on how advanced you are in terms of your Julia usage, beginners may use more Python alongside Julia. Advanced Julia users still use Python, but maybe not to a large extent, right? So
even
the reality is that people will still, in their day-to-day work, use multiple languages, right?
Absolutely, and including Excel, right? I mean,
right.
Every tool has its purpose, and I often find Excel to be more productive than often writing a script. The survey actually has a very clear sort of number, which shows that 50% of the people who took the survey use Julia for at least 50% of their work. So maybe that's the best way to articulate what you just said.
So the survey also has a section that basically summarizes what users like most about Julia and what users like least about Julia. So maybe you can give us a quick summary of both sides of that equation.
Let's see. What do users like most? I think I don't have the survey in front of me right now, but if I had to sort of recollect from my memory and imagine what users. So what users love about Julia is obviously the performance, the ease of use, the speed, the fact that a lot of people say they really love Julia because it is the language of the future. So even if they may not be using it today, they know that it's the language that they will have to use soon.
I'm looking at it now. So open source is another thing, and then multiple dispatch, which is a bit technical. So why don't you give us like a very simple explanation for what that is?
Yeah, so multiple dispatch is, I think, one of the key things that makes Julia what it is and enables what it does. My co-founder, Stefan Krapinski, actually has a wonderful talk on this topic, which is linked right from the julialang.org website, titled The Unreasonable Effectiveness of Multiple Dispatch. When we started, it was very clear to us, on like day one, that we do not want to go purely sort of single dispatch object-oriented style of programming. And we wanted multiple dispatch, which basically is just a very simple thing. It says that the method that you pick depends on the types of all the input arguments, not just the first one. So single dispatch or object-oriented systems are dispatched on the type of the first argument or the object that you call it on. Whereas in multiple dispatch, it's the method you pick is based on the types of all the input arguments. And this, over the years, this is one of those kinds of things where we appreciated its power a lot more than we had anticipated when we started. It was pretty clear when we started it was powerful, but it was not only powerful in the technical terms, but also in terms of building the community. So one of the things that people love about Julia is that it is extremely composable. So you can take 2 or 3 different kinds of libraries in Julia that were not written to work with each other, but you can compose them in ways that you could not have imagined before. So a common example that I like to give is, let's say you have an LU factorization code, and you have a new data type that you created called, or let's use the one that's in Julia called big float, right? So it goes beyond 64-bit floating point numbers. the generic LU decomposition method in Julia, which knows nothing about the types of data that are passed in, can transparently take this higher precision or lower precision data, as we see in machine learning, and just work. And the person who wrote the LU factorization and the person who wrote the high precision numeric type don't know about each other, but because of multiple dispatch and the way the language is designed, it's very easy to compose these things. So multiple dispatch really allows these separation of concerns in the language, and it really sort of makes it easy for, the most interesting thing that it made possible for us is that, you remember how I mentioned that you pick the method based on all the input types?
Yep.
So now what happens is that when I write a new package, I can extend something that is already written in Julia or in another package by adding new types. And the compiler finds this information useful because when the compiler is doing its type inference, it has to pick one of the several available methods. And now once it picks one of them, it just compiles only that one definition and sticks it into your compiled code. So for example, in Python, when you do 1 + 1, it has to look up its table of all the methods for plus that it has and pick the one that is integer plus integer. Julia at compile time will be like, oh, this is an integer plus integer. So out of my 200 plus definitions, I'm going to pick the integer plus integer, and it essentially gets reduced to one assembly instruction and stuck into the right place. And that's how you really get the performance.
I see. So the survey, so I'll put you on the spot, the like least. The first one that I'll highlight is not something unique to you. It's basically true for most of the open source projects that I speak with, which is documentation and tutorials need to get better. That's an ongoing battle, right?
It's an ongoing battle.
Yeah. Secondly, so these I'm not quite clear on what they're talking about here. So it takes too long to generate the first plot.
Yeah. So the time to first plot, or TTFP as it's often called in the Julia community, refers to sort of the compile time of the Julia compiler. So Julia is actually an ahead of time compiler, but it gives you a JIT experience, right? So when you type something at the Julia prompt and hit enter, it's actually going to compile it if it's the first time it's seeing that piece of code. And sometimes a compilation can be a bit too slow for an interactive use case. So if I'm compiling a large C++ program, I type make and then I go and do my thing and then I run it. But when I run it, I don't feel the compile time pause. Whereas in Julia, sometimes this can be quite large, and it turns out, of all things, plotting libraries are incredibly sophisticated and complex, and it takes a long time to compile them. And that's what people refer to the time.
So this would be, Viral, this would be kind of someone from the R world who's used to writing one line of code to plot something in R, hits enter, and then it plots. In Julia, they won't get that experience.
Oh no, you get that experience, but in R, that plot comes up within a second. In Julia, it used to take upwards of 30 seconds, but with Julia 1.5, we are sort of close to that 5-second mark now, 5 to 10 seconds, which I feel is, and that's only the first time. The second plot comes in a millisecond. So
right. It's the first time because it's trying to figure out, it's trying to compile.
It's compiling the plotting library, and that's a big one. And this is nothing specific to plotting. It's specific to any large library that you load. But plotting tends to be one of the first things people want to do. And so that's where they run into understanding what's going on under the hood. That's when they start sort of understanding the Julia compilation model and, sort of opening up the hood sort of thing.
So the last thing that I want to highlight in the survey, that users like least, is another one of these things that you folks actually have less control over, which is packages aren't as mature or well maintained. Yes. But there's not much you can do there because that's up to the package writers in many ways, right?
It's up to the package writers. It's up to the community. We try our best to sort of make it happen to the extent that we can convene the ecosystem. But I think that, so for example, Julia now has 4,000 packages, which I think is huge because you can also call every R, Python, and C++ library ever written in Julia.
What's the performance overhead for calling an R package?
It's very low. Like Julia can call Python at the same sort of speed at which it would call, but a Python function would call Python itself. And not only that, we have the same low overhead for a C function. So if you're calling a C function from within C, Julia calling C is roughly the same overhead. So you can actually inline a C call, which is a tiny C function in a Julia loop, and it'll all get compiled and executed as if it was all, you'll get the native code performance in C.
So help us get a sense of a typical Julia user, right? So in other communities, so people are using notebooks. Although I'm now a Visual Studio Code person with the Streamlit. I don't know if you've heard of Streamlit.
I've heard of it. I haven't tried it out yet.
Yeah. So what are Julia users gravitating towards?
Jupyter is big in Julia even today. So, and as you already probably know, that JU in Jupyter stands for Julia. It's Julia, Python, and R. So it's been great marketing for us. Thanks to Fernando for picking that name. There's a new notebook environment called Pluto, which is a bit more experimental and does a few more, it is more aware of Julia. The notebook is more aware of Julia than say Jupyter would, because it understands the language. And so it's a very nice experimental new platform people are using. Our traditional sort of go-to IDE that we used to recommend was Juno, which was based on Atom. But this JuliaCon, which just happened about 3 or 4 weeks ago, we announced the big move from Atom to Visual Studio Code. And it's almost, I would say it's feature complete for the most part. I mean, the power users still find a few things, they have to complain about, but I would say that as a new user, you just follow the instructions on the website and you get a beautiful VS Code experience out of the box. So, and that's, by the way, what we are integrating into all of our Julia computing products. So from from VS Code, you'll be able to sort of launch parallel computing on the cloud with a single button and all. So that's, we're going in all the way on VS Code.
So that's a good time to segue so to some high level trends. The first two you've covered, so you've kind of explained that machine learning is well supported in Julia. Julia has good answers for distributed computing. So the third trend would be cloud native and serverless. So what does Julia have to say there?
Cloud native is easy. So we support all the usual kinds of things. I mean, there's nothing in Julia that makes it any more or any less cloud ready than any other language per se. We have very good AWS bindings now, so it's very easy to roll out, and integrate with AWS APIs. Slightly less mature, not slightly, I'd say quite a bit less mature Azure bindings, and even less mature, Google Cloud Platform bindings. But I would think it would, the AWS bindings satisfy a huge number of users, a large part of the user base. Serverless, we are, if you think of something like AWS Lambda, Julia is not sort of suitable for it at this point because of some of the compile time latencies and memory requirements. They're just a bit too tight for Julia at the moment. So there are hacks that exist, but I think they're not a good experience at this point.
Okay. So we talked a little bit about machine learning, but inside machine learning, there are kind of specialized communities and libraries, right? So, yes. So the things that come to mind because of the rise of deep learning would be NLP, natural language processing, computer vision, and speech technology. So NLP in particular is pretty standard task that a data scientist will need to have an answer to. So what is Julia's story around NLP?
We're seeing a lot of, so we have a package called textanalysis.jl, which tries to provide sort of all your standard NLP tools and workflows. So, that's just...
So that's maintained by you or someone else?
It's all done by the community. Okay. Everything in Julia is done by the community, by and large. Many of the community members work for us at Julia Computing, but I would say that even Julia Computing is generally a smaller part of the larger ecosystem. So Julia has, like, if you count the contributors to Julia itself, and let's say all the packages, that number is almost 5,000 contributors.
Wow.
So 1,000 contributors to the Julia language itself, if you go to GitHub, and then there's 4,000 other packages. So, well, that if you sort of add it all up together, I think, somewhere like 3,000 to 5,000 is a fairly large.
So how does this NLP package compare to what people can find in Python, like Spacey or Allen NLP or the like?
I think it is probably not fully there yet as compared to something like Spacey. But what people do is that they use Julia for the high performance bits of their NLP things as they would like it to be. And you can just PyCall Spacey. It's a single line of code to call any Spacey function. So unless there is a reason to sort of rewrite some parts of Spacey in Julia because it would give you much higher performance, you just simply call the Spacey and you just kind of get what you need.
So is that the Viral? Is that kind of characterize how people end up using Julia, which is basically if they can get by with calling something from Python, they do that. And then they only kind of really rewrite everything from scratch when they're forced to.
It's usually the other way around. So usually people, when they're starting a project, they'll be like, okay, is there a native Julia version of this thing that is somehow better? Because then it's easier to debug. You don't have this cross two language problem, debugging across libraries, and all that stuff. And the decision is usually made by the package author, right? Like, because at the end of the day, contributor time is the most scarce resource in the community. Even though there are 3,000 to 5,000 contributors, all of these people are sort of doing this as a hobby, right? Except for people who are paid to work on Julia, which is very few. So those people, when they're making the decision of what I want this package to look like, usually we'll look at the tools around, we'll see where Julia's competitive advantage is, and come up with a design where they leverage Julia for what it's good at, but then pull in things that are best in class elsewhere. And a good example is, for example, in linear algebra, right? We don't rewrite the BLAS and LAPACK linear algebra libraries. We just plug in the Fortran libraries.
Right.
And by the way, we include we have a system called Binary Builder. So we provide precompiled platform optimized libraries for like almost 500 open source packages out there in C, C++, Fortran, and so on and so on. And people are trying to add Rust, they're adding Python, they're adding all these new things to Binary Builder so that Julia users don't have to care, right? They just call a function. Under the hood, it may call C, it may call Julia, it may call Fortran, it may call Python. It's all sort of very transparent.
So since you're the CEO of Julia Computing, one of your jobs obviously is to get people excited about Julia. So I'll put you on the spot. So let's say you're giving a keynote and then you have a few slides to rattle off some really good production use cases, commercial.
Right.
What would they be?
So yeah, that's one of my favorite commercial production slides is a system that we deployed at Aviva. Aviva is one of the world's largest insurers, and the whole regulatory aspect of Aviva's work about so they have to do these massive simulations on their entire data set to satisfy the regulator about that the company is holding adequate capital and is ready for any sort of unforeseen insurance event that shows up. And it's a very complex system because it's not just one code that runs, it has to run for every sub-organization of Aviva, which comprises of 300 companies in the larger holding company. And that entire workflow is written in Julia. It replaced an old IBM algorithmics code base, and the overall improvement was 1,000 times. So it basically ran 30 times faster, but used 30 times lesser hardware. So roughly you got like 1,000x improvement over what was state of the art. And the best part of that story for me was that the people who wrote the Julia system had only experience with Excel macros before. They were not even real programmers. So they were just able to pick up Julia and run with this system. Of course, that was a proof of concept, but then when they had to actually deploy it, the IT team came together and all the other parts of the organization came and did their thing. Julia Computing played it, came in and provided the enterprise support and guarantees. a company would need, to deploy something like that in production. So it's one of the use cases that I really like to talk about a lot.
I imagine you have a ton of use cases that you are not allowed to talk about in the hedge fund
Yes.
finance world, right?
Yes, those guys don't want us to talk about that competitive advantage out there. We have a BlackRock case study because they graciously presented it at one of the early Julia cons. So that one's public. The other amazing set of case studies are actually in pharma. So we have, amazing case study that we were able to publish, which is also going to win the best paper award at an upcoming top pharma conference called ACOP, and where Julia showed 175x improvement in performance on a single node with a GPU or an existing code base that they had. So that's we're seeing.
Have you guys been able to make inroads in some of these Bay Area tech companies?
They're all using Julia.
Okay.
I know for a fact that folks at Amazon are using Julia. There are actually, I've seen Amazon job advertisements that specifically ask only for Julia skills. Because Julia has some of the best optimization libraries. So, people who work in like logistics and like, inside of things like Amazon Prime, I imagine, are the ones that want these things. I also like some of the key contributors to Julia are also from some of these large firms. So like a lot of the optimization tools are coordinated by a group at Google. I mean, they were at MIT before, they're now at Google. And I believe they run some fairly large internal workflows using Julia there as well. Another example, I think, is John Miles White,
Yep.
Very famous name. Is at Facebook. I do not believe he's using Julia at Facebook, but he's a major contributor in the Julia ecosystem.
Very early cheerleader and user and evangelizer, right?
Absolutely, and package author as well. And he's sort of moved ideas back and forth between his sort of real day job and between what the Julia community does. So I would say that all the major I've had interactions with folks at Netflix who are deploying Julia servers. So it's
so you folks need to basically organize all of these use cases, and is it easily discernible from the Julia website?
If you go to juliacomputing.com, so the company has we have an industries and a case studies page, and you can actually I could just do a screen share. Is that
no that doesn't work? Yeah, it's a podcast.
Yeah, right? I never knew. Yeah. But if you go to the juliacomputing.com website and go /case studies and industries, you can see these examples. We've done a good job of putting them all together across a variety of different industries.
So let's close this segment before I briefly close this podcast with your book. This is a question I ask people who are leading open source projects. So at this point in the project, what metrics do you track closely? And how does it compare to the metrics you guys started out tracking in the early days of the project?
One of the metrics I track personally is Julia downloads. And over time it has become very hard because of the explosion of CI. Because now everything is so we've worked hard on sort of filtering out CI downloads from our download stats, but we report a number 17 million downloads right now. That one is inclusive of anything that hits the Julia web server and tries to download Julia itself. And the reason we track that metric is because that's the oldest time series that we have, and we've seen a doubling every year ever since 2012. So and the doubling continues even today. And so that's sort of a major one. I also look at the number of users on Discourse, the number of users on our Slack channel, the number of subscribers to our YouTube channel, so on and so forth.
Which brings me to, I'm running a Twitter poll as we speak, which I will write about right now. I have noticed, Viral, that a lot of open source communities are interacting with their users on Slack, which is interesting to me because, new users still use Google. So they'll encounter a problem, they'll type it on Google, and that's not the Slack stuff. Slack is great because one, You get if the core group is active, you get an instant answer and very personalized to your question. But then all that knowledge is buried behind this Slack channel, right?
Not only just buried, it's lost because Slack, oh,
Yeah,
we are
the search is
you
not
can't,
very good.
no, you can't search it because we are on the free Slack. Like we
Oh,
are
I see.
6,000 people on the Slack. There's no way we can pay for them.
Right.
It's a crazy large Slack, right? And we try to reach out.
Can you write like a thing where you scrape it right away and then make it available, or does that violate Slack's terms of service?
It just seems like so much work to keep up with it.
No,
But
but that's a lot of knowledge, right?
if such a tool existed, we would. So there is for that reason, there's a concerted effort in our community to find an alternative to Slack, and a lot of people are working. A lot of our community sub communities have moved to Zulip as a result of that.
But you folks predated Slack, so how did you end up in Slack?
We predated Slack and Discourse both. So we started, our original thing was on Google Groups.
Yeah.
That we translated over to Discourse, and Discourse is still significantly more active than Slack. The GitHub is still significantly more active than Slack, but Slack just serves a different purpose in terms of the quick real-time back and forth. I think it, like you pointed out, that knowledge is lost. Also, it's not structured very well, right? Because it's sort of in this stream of information. So I try to encourage as many people as I can, like hey, at least when there is a takeaway. If we answer a question, let's make sure we put it on Stack Overflow. If there's a design discussion, let's make sure it goes to a relevant GitHub issue. And let's keep Slack to sort of coordination and discussion and sort of impromptu stuff, but let's not make it the place where we do design. Because anything that ends up on Discourse or GitHub gets indexed by Google, and that's how you grow the community. That stuff compounds, whereas Slack, it does not compound, right? I mean, Slack can't scale up.
Right.
But it's fun place for people to hang out.
All right, so let's close with a completely different topic. As I was preparing for that podcast, I realized you wrote a great book with the co-founder of Infosys. Man, how did that happen? Number one, and number two, give us a high-level overview of the book.
Yeah, so the co-author of my book is Nandan Nilekani, who was the founder and CEO of Infosys and now is the chairman still. Nandan was my boss at he was the minister in the government who was actually tasked with implementing what was back then called the Unique ID project, or now called the Aadhaar project, which collected 1 billion people's biometric data and deduplicated them against each other.
That's so big data.
It is truly big data. I mean, I actually started my work on the Unique ID system and Julia like literally the same day.
I see.
Yeah, so the startup I was working for was shut down, got acquired by Microsoft. Back then I had to move back to India. My visa expired from the US. I met Nandan roughly at that point, and we started discussing the Julia project on email. So two of the best projects I've done in my life have literally started at the same time. The book is called Rebooting India, and Nandan and I describe what it takes to run a startup inside of government, basically.
I see.
It is so difficult to work inside such a behemoth of an organization. The government of India is one of the largest organizations in the world. Government is a different beast, right? Like, it is not operating in a market, right? Like, if it does not do well, you can't, go to another provider, right? You have to sort of do right. And then there are checks and balances, and there are multiple masters and people who really don't like you. They have opposing voices for all kinds of reasons, right? From data privacy to security to someone wanting a promotion and not liking that, your department steps on their department. And amongst all this, bringing technology into government in a way that has never been done before, and making a digital ID the foundation of digital India today. I mean, that was a game changer when we started in 2010. We didn't even have reliable data, mobile data coverage in India when we started, which obviously was a bet we took and changed. Right now, you can get, the cheapest data transfer rates, fastest rates in every remote corner of India. So Rebooting India describes that experience of working in government. And the reason I really wanted to write that book was because it was one of the most difficult journeys that I undertook and one of the most satisfying things that I ever did to build something that impacted the lives of so many people. And I knew that there are many other people like me who come from a technology background who sort of have this view of government, which may be that, oh, the government is antiquated, it's so behind, like I would never imagine myself ever having a role there. And we wrote the book, for that reader, right, of how to get these things done in government, how a person like me who's a technologist can find a role inside the government and actually make real change, and what to watch out for and how to do it. And so it's a very practical, experience-oriented book, the first half of it. And the second half of the book sort of takes our experience and projects it on solving a number of different challenges in India using technology.
Oh, so since that book came out and you won the Wilkinson Prize along with Jeff and Stefan, which is a prestigious prize in numerical computing, you're somewhat of a celebrity in India. Does that mean that the Indian system integrators like Infosys now have Julia on their radar?
They definitely have Julia on their radar. I actually, every time I'm in India, I visit as many places as I can and companies to talk. I was recently at Infosys meeting with their top management. In fact, I think in the next 2 or 3 weeks, I'm invited to give a talk at TCS. Obviously, that's online. So I think, at the end of the day, Julia is still relatively new, and a lot of these companies are sort of, their bread and butter comes from, doing Java or C# for very large corporations like Bank of America or Fidelity and so on and so forth. But they're all seeing sort of, interesting applications coming up where they need to use Julia, right? So, because they all have their customers asking them, like, what is a differentiator for you, right? I mean, like, can you take us through, we're seeing Google do all these amazing things. I'm an oil production company. Is there any machine learning I can do? And that's where Julia comes in, because it can combine the science that is involved as part of the oil exploration with the machine learning and actually become a real business solution. So I'm seeing sort of these things beginning to light up now in the Indian IT ecosystem. The other I think point worth pointing out is that some of the contributors to Julia, because I did all my Julia work in the when I founded the project with my co-founders, I was actually in India the whole time. And so there was a very sort of strong community of contributors that I was able to form out there. And that community continues to sort of drive Julia forward.
Are they in the usual places, Bangalore, Hyderabad, and Pune?
Actually, surprisingly not. So a lot of them do come from those places. But one of the major things that we've seen is, we participate in the Google Summer of Code. And every year, without fail, half the students that we end up picking up through a very open merit-based process, about half of them are always from India. And they are from all over the country. I mean, from small college towns, people coming from small cities. And it's amazing, if you have somewhat of reliable electricity and reliable data network, I mean, you're no longer constrained to, the 2 or 3 big IT hubs in India. It is literally, we receive contributions from everywhere across India, like from people in small towns, villages, colleges, communities. It's amazing.
And with that, thank you, Viral. It's a long time coming, and I'll bring you in back to the podcast in a year to check back in the progress of the project.
Thank you, Ben, for hosting me, and this was a really fun conversation.
Thank you.